All right, now we're going to look at finding the direction angle of a vector. The direction angle is the way to specify the direction the vector is going. It's also the angle that the vector makes with a positive x-axis. And I'm going to add to that when we say that the angle that the vector makes with a positive x-axis, that means we're thinking about the angle in standard position, like from 0 to 360. And the other way, so we'll see it written that way sometimes, like, an angle at 240 degrees, and we'll know that what quadrant that's in. The other way we can see this written is a compass direction, which is what we see in our example. Okay. If it's a question that you're having to answer for me, I don't mind if you answer it as a standard position angle or a compass direction angle, but sometimes you don't have a choice, so you do need to be able to do either. So let's look at our example. It says a ship is leaving port and it sails for 75 miles in a direction 35 degrees north of east. So they gave me a compass direction. So when we're given a compass direction, we know this is the east, south, west, and north. So if they give you any compass direction, you actually look at the last direction first, and that's the axis you're moving off of. So we're moving of the east. We're moving off of this axis, and we're moving north, so we go up from that axis. So 35 degrees north of east. So off of the east axis in the north direction. They could have very easily just said 35 degrees since this is a first degree or first quadrant angle. They didn't need the direction this time, but they put one. That's what it means. All right, and we know the magnitude or the distance, the length that they are sailing in is 75 miles. So that's the length of this vector. So they were here, they went for 75 miles in this direction. It says find the magnitude. Magnitude is just a fancy word for length of the vertical and horizontal components. So they want the horizontal component, how far to the east did they go? And they want the vertical component, how far north did they go? They basically want the x and the y. It's a triangle, right? Vectors are trig. They have different words, they have different meanings, they have better application, but they are trig. So this is a right triangle. They want the two legs of this triangle. We did this in polar, if you've done the polar stuff already, where if I want the y value, then I'm basically just going to be doing, right, opposite over hypotenuse is sine. Opposite over hypotenuse. So really I'm just going to be doing 75 times the sine of 35 is going to give me the y. And if I want the x, I'm going to be doing cosine because that's adjacent over hypotenuse. So 75 times the cosine of 35 is going to give me the horizontal component. So you want to make sure you're in degree mode and then type these in really quick. So what we found is horizontally, from where they started, they were 61.4344 miles in the horizontal. They were 43 miles vertically from where they started. And in a straight line distance, right, that was a 75-mile distance. So if I wrote this in component form, the horizontal component would come first and the vertical component would come second. And this would mean 61.4 miles over 43 miles up. Okay. All right, let's look at one more example to kind of go through this direction angle, because you will also be asked to find the angle sometimes, and I know that we haven't done that yet. So this says we're going to do a few things. Find the magnitude and the direction angle of a vector. This vector is in component form because they used the less than greater than on the outside. So that means this vector starts at 0, 0, and it ends at -2, -5. So that's what my vector looks like. First thing you'd want to do in this case is put it in component form. That's already done for us, but if they had given us like the initial and the terminal point, go ahead and put it in component form first from video 1. Number 2, draw a sketch to determine the quadrant we're in. We are in quadrant 3. All right, and find the magnitude. Magnitude is like Pythagorean theorem. So this one is, 2, 5. So we're going to do 2 squared plus 5 squared, and then square root it. I can't simplify that. So the magnitude of this vector is the square root of 29 units. They didn't tell me what I'm in. All right, that is finding the magnitude. The rest of these directions are how to find your direction angle. Okay, so let's talk about finding the direction angle. To find the direction angle, I need to start by finding this inside angle to the x-axis. And to do that, it's talking about tangent. The reason it's talking about tangent is we know our y and we know our x. So I can see that my x was negative and my y was negative. So I would be doing inverse tangent of y over x to find this angle, the angle from the x-axis to the vector. So I'm going to do that, inverse tangent, and I get 68.2 degrees. So 68.2 degrees is just this portion. I have a few options on how to write this angle. I can write this angle in standard position, meaning if this is 0 degrees and I go all the way around to the x-axis, that's 180, then I would have to add 68.2 to get, to that vector. So I would do 180 plus 68.2 and find that this vector in standard position is 248.2 degrees. That's a fine way to write it. It tells me exactly where it is. I'm in the 3rd quadrant. I'm exactly where I need to be. But sometimes, like we mentioned before, they do compass directions. So what they would say is you are 68.2 degrees. And remember, we do the last direction first. You are off of the west axis and you are moving in the south direction to get to this line. That's what this angle is. It's off of the west and it's moving south. So we would say south of west. Okay. There is an IXL that deals with these compass directions. If you are struggling with them, do that one and let me know if you're having trouble. The hardest part is you just have to get used to finding what axis you're off of and then move to the vector. Okay. I couldn't go off of this axis because I don't know this angle. If you had subtracted and found this angle, then we could have gone off of that axis and gone this way. So it's just in what angle you know. Okay. All right. Let me know if you have any more questions. There's going to be one more video dealing with moving vectors to add them, but I'm going to do that one actually just doing a Delta Math example because it's already set up, it's interactive, and so I can kind of show you what to do from there. All right, bye.